I'll just kick off then by just doing a short introduction to this fifth and final PH Easy webinar from the Passive House Association of Ireland. My name is Barry McCarn and I'm the Vice Chair of the Passive House Association of Ireland. And we thankfully again have Shane Kinsella from MosArt, who's going to share his knowledge so far with easyPH. And on this, it's of course, for some of you who know me, it's going to be my own project that's going to be featured. But the focus of today is going to be really on the certification process, and Shane's going to take us through what's different with respect to PH Easy in the process now with its introduction. So without further ado, I'll hand over to Shane, and he can take it away.
Thank you very much, Barry, and congratulations on your new role in Core Retrofit as Managing Director. I'll be looking forward to working with you on future projects and stuff, and all the best in it. So today we are going to discuss the certification project using easyPH. So in our previous webinars, we have discussed the various approaches that we have to follow to fill up an easyPH project and to enable us to accurately model it and work out all the various inputs. So today we're not going to really spend that much time in the easyPH. We're actually going to spend a bit more time looking at the documentary evidence requirements and stuff like that. So I suppose anyone who's been through the regular Passive House certification route will be familiar with a lot of these documents, as will anybody who does a lot of work with BERs or EPCs, as they may be in other jurisdictions. So a lot of the documents will be largely the same. There are some differences, but by and large the same. So I'm not going to delay too long on it today. So first thing we're going to look at here is to say, right, well, what's the criteria here? So I suppose just to be very clear here, the criteria is exactly the same. There's no difference. The 15 kilowatt hours, 10 watts per meter squared, 0.6 air changes per hour, PER of 60, etc. all applies as normal, as does the overheating percentage of 10%. So there is no difference in our certification criteria. However, there are limits on the types of buildings that can be certified using easyPH. I think it's important to be very clear on that, because I suppose rather than expending effort in design offices saying, well, actually we can go easyPH, and then to find out that your building is not within the criteria. So there are three categories of building or of dwelling that can be certified with easyPH. I suppose you can work with a Passive House Classic, you can work with Passive House Plus, and you can work with PHI low energy building. We are not able to use easyPH for any of the ENERFIT standards. Okay, ENERFIT is just not a runner for easyPH. There is a more dedicated easyPH ENERFIT approach due to come out in the future. I don't know the exact detail of how that's going to work at the moment, but we can't use easyPH for ENERFIT buildings. We also cannot use easyPH for Passive House premium buildings. They must go the standard certification route, and that's primarily to do with primary energy. Given that the limits are so tight for Passive House premium, it makes more sense to go the standard certification route. And last but not least here, and this would be the case with Barry's dwelling, which we've used as the guinea pig for this example, is that you can use easyPH for a retrofitted dwelling if you are certifying it to Passive House or low energy building. So there's no problem with it being a retrofitted building, provided that it's been certified to Passive House or LEB. So because that's a question I've had asked a few times, so there's definitely no problem there. So that's, I suppose, the general approach. So from a criteria perspective, there's really no difference. So I suppose the various inputs then into our easyPH for certification. So we'll start with our opaque fabric. So all our usual walls, roof, floors, etc., all go in as normal into the U values tab. Should be nothing unusual there for most projects. We then put in our thermal bridges where if we're going a thermal bridge free approach, we don't need to enter thermal bridges. If we're going a model thermal bridge approach, you do enter the thermal bridges. So that feeds into it. We put our windows in as normals. We put in our UF values, UG values, our G value for our glass, our psi install, all that good stuff goes in as normal. There's nothing unusual there. Our shading is usually in most cases completed using easyPH. It can be modeled manually. Generally it's recommended to go easyPH just for from accuracy and ease of evidencing. We then look at our heating system. So as we've looked at in the previous webinars, it's quite straightforward to put a heat pump or a boiler or whatever into easyPH. There's a simplified approach and a detailed approach. That decision can be made by the designer. We can put in our domestic hot water then. So similar to the heating, we can put it in as a boiler or a electric system or heat pump or whatever our approach is. We can then put in our ventilation system and put also, part of that is our air tightness numbers go in that section as well. And finally, where we have renewables being installed, then we put in our renewables then for our solar PV or our solar domestic hot water. So they're the basic inputs, really not any different to a standard PHPP. Once all those things are entered, the building shows it's compliant, then the building will be certifiable then in accordance with Passive House. So we'll get in a little bit deeper and we'll look at the opaque fabric. So as I said, for a lot of people, this will be familiar, particularly if you're doing BERs or EPCs or you've been down the standard route. They should all be pretty familiar. So what we need to do first is we need to get data for our insulation products. So there's various sources of that. I have some examples here, which we'll have a look at now in a moment. So we can get data sheets, which should have the CE mark, etc., and stuff like that. I'll show you an example in a moment. We can use a declaration of performance, which is a document should be available for all insulation products placed on the European Union market, that they're typically issued as a parallel document under the UKCA system, so they're perfectly acceptable. No issue there. We can use a CE mark label. We know a lot of manufacturers will put a CE mark label on their packs of insulation with all the necessary information, so they're perfectly acceptable. We can use an agreement certificate, which is issued by NSAI in the context of Ireland, and then BBA in the context of the UK, and I suppose also for Northern Ireland as well, as covered under BBA. So those documents are all perfectly acceptable. You are only required to provide a single document. So if you have the two, you're free to use them as evidence. But if you have a single document, that will cover you. The critical thing here is that we have the thermal conductivity and that the ISO standard is referenced on it, that it was tested to. So once those two pieces of information are on it, they're really the biggies that we're looking for. If your insulation product is foil back, then, which is very common with PIR products, and you also are using it with an unventilated cavity and applying a thermal resistance to that cavity, we need to get some details on the emissivity value of the foil. So that's typically dealt with by a data sheet. In some cases, it's on the agreement certs and things like that. So if in that case your requirement is met, but some information is required on that. And last but not least, then is our old friends here in these buildings, which is fixings and wall ties and all this kind of stuff. So we see all kinds of different wall ties and various types of fixings. So some are thermally broken, some are not thermally broken. There's various approaches for calculating the values for those. You can do it in PHPP. You are free to do that in an outside calculator. I suppose a common one would be the BRE calculator. There are other types as well. There's no issue with any of those. And probably one of the most important things we see happening, and it often gets overlooked in insulation, is this little bottom photograph here has screws going through an insulation layer, and these often get omitted from the calculation, but they can actually have quite a considerable effect on the results. So we need to just make sure things like that are all captured. Or even nails and things like that for going through maybe an insulation layer with a batten on, maybe nailed through into a timber frame or something like that. We need to make sure that those fixings are accounted for. So that's, again, all fairly standard stuff there on that front. So when we get data sheets in, I suppose this is a typical GUTEX data sheet, which I was able to get from the Ecological Building Systems website. A fairly typical data sheet we would expect to see in. The product details are given there. So in this case, GUTEX multi-term. The thermal conductivity of the product is given there, 0.04. The ISO standard is referenced, which is the EN 13171, which is fine. and there is a CE mark on that document as well. Now, it doesn't have to be on the exact page of the data sheet, but ideally there should be a CE mark or a UKCA mark or something like that on it, which confirms that it's a valid document. So it should be a fairly standard check, I think, for most people. The other type of information we can use here is a declaration of performance. So here's one for Core EPS 70 Silver. Again, a product many guys out there will be familiar with. Again, you've got the product information. In this case, there's a notified body which serves as evidence that the product has been properly tested. We have the ISO standard is noted there on the top. We have the thermal conductivity provided, and that document is CE marked. So that's perfect evidence. I mean, if you don't have one or the other of these things on it, it's not a deal breaker. I suppose it's not as rigid. We're not as rigid as maybe with BER on it. So as long as the document, you know, is plausible and it gives the values, we can typically accept it. So I suppose the usual answer here: when in doubt, check with your certifier if you're in any doubt about your documents. Shouldn't be an issue for most projects and most products, maybe where you're using kind of exotic products or anything like that. So that's a typical example there. So here's an example now of an Agram insert. So this is an NSAI Agram insert. Again, product details are noted, thermal conductivity is noted, ISO standard. In this case, there is a foil on the insulation, so they have provided the surface emissivity of the foil given as 0.03. So that is noted there. So that covers you for your unventilated cavity. And then there's a reference to CE mark, and then on the document as well, which confirms that the document has been CE marked and therefore is suitable for use on the European Union market. Again, in the context of the UK, that would be UKCA mark is perfectly acceptable as well. So no issues on that front. So that's fairly typical kinds of evidence that we would see coming in, and you know, we're flexible, I suppose. Generally, in most certifiers will consider any kind of evidence provided, but I suppose there has to be kind of a minimum level of to say, well, actually, the evidence needs to be plausible in the first instance. So that's a typical example there of that. So get a little bit deeper, then we start looking at thermal bridges. I'm not going to delay too long on thermal bridges today. There's not a huge amount to say in it really in this webinar, other than I suppose there's two general approaches here. There is the thermal bridge free approach, where no thermal bridges are entered into PHPP. And then there is the I suppose accounting for thermal bridges approach, where you include the thermal bridges in your PHPP file. So I suppose when we're talking about, you know, thermal bridge free, we're looking to see are the junctions going to have a psi value of around 0.01 or less, preferably negative, but not always possible. But you know, positive up to 0.01 is considered acceptable. That does not need to be proven by modeling, just for clarification, but that's generally in the view of the certifier. So you know, we consider that to be met, where you have continuity in your insulation. You know, so around your corners and stuff, you've got no thinning of the insulation. You've got no you know, heavy fixings or anything going through it through the junctions, which would upset, you know, the thermal performance of the junction, and that you don't have, you know, very thin little layers of insulation going through those junctions. So that's the kind of stuff we're looking for there. And that can also be met by low conductivity materials. So I suppose your classic case being your wall to floor junction, where, you know, you have your blockwork wall meeting your floor. And I suppose the standard solution in a lot of blockwork buildings nowadays is to use a low conductivity block where the wall meets the floor. So that's considered a thermal bridge free approach for the purposes of passive house. And then I suppose the last thing is we don't want to see steel or concrete going from inside to outside. So, and to be honest, whether you put a thermal break in or not really doesn't change that. At the end of the day, there's always a chi value on those junctions, and they can be quite high even with decent sized thermal breaks. So there should be nothing like that when you're going the thermal bridge free approach, and that should catch the majority of single family homes. So also we look for a bit of redundancy in the project. In this case, I suppose we would consider that to be typically less than or equal to 14 kilowatt hours per meter squared per year. I suppose that would cover most projects. If your project had a lot of metal framing or stuff like that, that could run the risk of very high levels of thermal bridging, then that becomes that needs to be even tighter. That limit does. So, but typically around 14 is our starting point. There's no kind of hard and fast rule on that as such. Alternatively, if the building has been certified on space heating load, we would look to see that down around the 9 watts per meter squared. So they're not red lines as such. They're just guides for certifiers that we, most people tend to use. It's just them as a guideline to say, is there a bit of room in the PHPP model? As the project moves on, that room can get less and less if it's clear that the building is thermal bridge free. Then that doesn't become so much of an issue. And in that case, then you'd enter no SI values into your PHPP. That keeps your costs down for your client, keeps your costs down for your architecture firm. And it also just keeps the complexity of the PHPP modeling managed to a better degree, because if you know thermal bridges, then you have a hell of a lot less paperwork to provide. It's also just important to point out too about window installation SI values. So whether you go thermal bridge free or not doesn't exempt you from requiring window insulation SI values. There's a couple of ways you can get those. So if it's a certified window, you can often get them from the certificate for that particular window that you're using. If your build up, or if your typical build up has a SI value provided, that's generally acceptable. In many cases, the passive house designer will model those just on their own and then put the SI values into their PHPP. That doesn't change you've been thermal bridge free. It just means you've got an accurate window installation SI value. So again, if you're in doubt, contact your certifier, and I suppose there's a bit of discretion with certifiers as to what they'll insist on. So individual certifiers will have their own approach typically on those things. So that covers a thermal bridge free approach. And I suppose here's typical examples. I'm not going to delay too long on this. So we can see here that we've got an aerated block, and where the wall meets the floor. In this case, we have our typical passive slab there, which is core, do a lot of work on that. So that's one there that's considered thermal bridge free. We have a detail here from the acceptable construction details, which shows a dormer roof, and it shows where the rafters are meeting the upper rafter ties and stuff like that. So we can see that we've got unbroken insulation. This is a steel frame building from the ACDs where we've got insulation outside of the metal studs, showing clear continuity, so no issue with that. Here's another example provided by Roadstone, where they have put in their low conductivity block, and they have placed it on a block wall foundation with a timber stud wall above it. So that's considered thermal bridge free. Here's an example from Mannock, where they have an eaves to externally insulated wall detail, again showing the continuity of the insulation. That would be considered thermal bridge free. And lastly, here is a sill detail under a window with a piece of compact foam. So that's typically provided by companies like Partel in Galway. Will provide those kind of materials, and that would also be considered thermal bridge free. So all these kind of materials and these kind of approaches will allow thermal bridge free design to be considered in your PHPP. There's no issue with any of those approaches. So when we have thermal bridges then that are modeled, so we enter those into PHPP, into the areas tab. Again, standard entries. There's no difference between easyPH and your standard PHPP. There's no requirement for any redundancy in that, so we won't be looking to see have you got a bit of space in your model that when you've thermal bridges entered, you can push it right to the wire, or certainly closer to the wire, rather than having to keep that bit of space. So there's plenty of sources these can be extracted from. So I suppose the obvious one is you model them project specific. So you take the actual architectural junctions and model them in thermal bridge software and get your SI value to external dimensions and enter them into PHPP. All, again, should be fairly standard for most projects. You can, of course, take them from other projects. That's no issue. That's maybe copyright things or whatever, but that doesn't, they can be used if they're suitable. You can use acceptable construction details, but you must convert those to external dimensions. And they're modeled in internal dimensions. So there is a tool in PHPP which will allow you to do that at the bottom of the areas tab. So you can convert those to PHPP values. You can use catalogs. So PHI actually provide a suite of catalogs with various junction types in it. If some of those cover your junction, you're free to use those. Insulation manufacturers will often provide thermal bridge calculations. It's not unusual to see that, like there's various companies do it. I think most of the major manufacturers provide that kind of information these days to suit their products. You can also then, where you're struggling with that kind of stuff, or maybe you have a small little bit of a small junction that's only maybe a meter or two or something like that, you may agree with your certifier that you're going to put a conservative psi value in that would cover the junction, in which case no modeling would be required on that particular junction. So that's, I suppose, a suitable option where you have, maybe a little bit more complicated of a design, or you have a specific junction that's relatively short. You may decide to put a conservative value beside that. Again, there's a bit of flexibility there with certifiers, I suppose. There's discretion in that. And I often get asked this: does the junction have to be an exact replica of the junction as designed? And the straight answer is it doesn't. Ideally, it should be, but if it's, as long as the junction is close, it's typically acceptable for use within your PHPP. What we will always do in a case like that is we will look to see, does a penalty need to be applied to that psi value. So I suppose if the junction you're looking at for the psi value and the architectural junction are a little different, we would typically look for that penalty to be applied, and that's agreed with your certifier. So in a case like that, you would agree that value and then just leave it at that. There's no further evidence required at that point. So we're going to get on and have a quick look at windows and doors then. So this is an absolute minefield, I'll be honest with you guys. This can run into very all kinds of data and all kinds of information out there. It varies so widely. I'm not going to go into massive detail today, I suppose. I've just looked at I suppose, when you use a certified window and use a non-certified window. Just to be absolutely clear, there is no requirement in the Passive House criteria to use certified components, particularly when it comes to windows. It's not written in anywhere into the criteria, so you're absolutely free to use non-certified windows. You will just need a little bit more data for them than you would for a certified window. So just bear that in mind. So for your certified window, you just get your window and door schedule from the supplier or the manufacturer. It should be straightforward for most projects. The Passive House certificate covers your frame type. So again, that's a pretty easy document to get from the Passive House components website. And then you need to ask your window supplier to provide you with a calculation or certificate for the glass that was installed, to provide you with the UG and the G value. So both of those documents would be required for certification, or sorry, all three of those documents would be required for certification with a certified window. So when you get to a non-certified window, it gets a little bit more complex, and we need to look for a little bit more information. We need to, again, just get the window and door schedule, again, a standard document, but we need to ask the manufacturer to provide us with UF values for the various sections that are installed in the building. So if you've got a mix of opening sections and fixed sections and doors and things, you may need an extra few bits of data from the manufacturer. You'll also need it for transoms and mullions and things like that, and for the various types. Anyone doing a lot of modeling will be familiar with mullions with 2 opening sections, 1 opening sections, flying mullions, fixed mullions, and same with transoms and all that kind of stuff. So if those occur in your building, you will need that information. Again, you need to confirm the glass, so you need to ask the manufacturer for a calculation or certificate to confirm the UG and G value. And last but not least, you need to get calculations for your psi installed, for your spacer, for your glazing edge spacer to put into your PHPP. And that will typically be provided on the Passive House certificate. So that's usually not required for certified windows. If they don't have models for those, but they do know the type of spacer that they're fitting, you can ask for a data sheet for that spacer and take the values from that data sheet for your spacer system. Typically, those values from the data sheets will be a little bit on the high side compared to what a modeled value will be, but many manufacturers will have that information to hand, so they can typically provide that. So we'll look at I suppose for window frames, the level of information that's required. So when you have a non-certified frame, you can typically get the information from BFRC certificates are a very good source of information. A lot of windows in the Irish market and UK market will have these kind of documents. They will typically provide you with the UF values as well as the glazed and edge thermal bridge, and often the UG and G values for the glass. So they will often cover you for all the various bits that you need. You do of course need to check that the glass installed is matches what's in the BFRC certificate. If not, you need to get the information for that. You can often get reports from EU notified bodies, which is often used for certification of windows. Those documents are perfectly valid as well. There's loads of those out there. We see various notified bodies providing them, so they're acceptable data. The manufacturer can sometimes provide them from their internal team. Will sometimes have modeled them and calculated them to EN 10077. So that's an acceptable approach. And last but not least, then if you can't get any information on the UF values, you are free to model them to EN 10077 by requesting the manufacturer to give you the thermal conductivities of the materials used in the window and running that in the thermal bridge software to calculate those. So that would be your final approach. Not done that often, but possible. For your glazing, then again, you can use a BFRC certificate or an EU notified body report. You just need to make sure that the glass exactly matches the installed glass. If there's any deviation whatsoever, you need to use the deviated value. So you need to request a data sheet for the specific glass installed. You can often, the glass manufacturer can provide you with a data sheet with the UG and G values on it, and those standards are typically EN 673 for UG and EN 410 for G value. So that will cover you for that. You can also get a CE certificate sometimes from the manufacturers as well, and that will again reference the values, and that's perfectly acceptable data as well. And again, look, always consult your certifier if you're using non-certified windows, because it is a minefield. And the last thing anybody wants is to find, midway or at the end of a project, you've got, a big surprise coming down the track that's going to make for, some very uncomfortable conversation. So, always make sure that data is in order early in play, and then, go from there with it then. So, that's fairly typical information required. So last but not least then is heat pump. So we went over this in detail in the last webinar, but this is a typical product fiche for a heat pump, and this is the exact heat pump that Barry installed in his dwelling. And you can see here that there's various bits of information required on that. So typically those documents have all the information that you require. In some cases they won't, and you may need to go back to the manufacturer, but they should cover you in most cases. And again, it's a case of checking to see, do they have stuff like SCOPs and test points and various bits, and then I suppose you're in a position then to choose which is are you going to go simplified or detailed approach. We would generally recommend going detailed approach if possible. If you have if you have the test points here, 35-degree or 55-degree test points. If you don't want to go that way, you're free to go the simplified approach and then just input the SCOP and drive on. It makes life very easy. So that is that is, I suppose, an overview of the documentary evidence requirements for easyPH. Now we're going to actually just take a few minutes just to have a look at the easyPH itself and actually the process within easyPH. So as we discussed on the first day, there is various boxes here that can be ticked off as the project progresses, and there's also some tasks here and some guidance given in easyPH. So as a rule, you'll follow that guidance within the easyPH tab, which will allow you to tick off your various bits as you go along. And you'll see there's little plus buttons on the left hand side there. Just make sure you go review and protect before you start working with those plus buttons, because they won't function without doing that. Most PHP files will come with the files set to protect sheet, so that's just something to be aware of. And then you can use your little plus buttons to open and close your various sections there, and look at your options. So you'll see there's a recommended approach, and then there's another components approach. Now it does say partly subject to surcharge. I suppose that's something to discuss with your certifier if you're in doubt, but like there would be an expectation in most cases, certainly in our office, that like we wouldn't be using certified components for U values, etc. I'm not aware that there's many certified building systems available, certainly in the Irish market, that would cover that. So you would expect to be calculating U values and things like that. And same with Windows, you know, you can use a certified window, you know, if you wish. Again, we would assume you would be using a non-certified window in most cases. So you know, there shouldn't be generally surcharges for that, most of that stuff. On things like thermal bridging, there may be a surcharge because there's quite a bit of extra work in it when you have to add a lot of, you know, add thermal bridges. So again, discuss that with your certifier. But the general process here is that you have 4 little X's here along for each section of the easyPH tab. And within that, there's 3 options. So you can hit the X, which means not completed, fairly straightforward. You can hit the bell, which means it's due for review, and then you can tick off the X to say select the tick then to confirm that it's complete. So you'll see there that there's various roles. So you have the main examination, which is typically your design stage assurance process, and you have your final examination then, which is your final certification. So I suppose you'll start, the designer will go through the various sections of the easyPH tab, and as they complete their work, they will tick that off to say they're complete. And then the certifier will take the file and review that. And then if they're happy with it, they will put their tick into the box, or if not, they'll click on the bell, which means it needs review. So it should be fairly straightforward for most people. It allows you to send the PHPP back and forward by email, or in some cases, people will maybe link it into 365 and maybe, you know, give a link to the certifier or something like that. That allows them to view the file in real time. So it's up to yourself how you decide to exchange information with your certifier. But there's a couple of ways of tackling that. So beyond that, then you know, again, just follow the guidance under each section, which should make it pretty straightforward for most projects. And then you've only got the tabs to fill out that are live in the easyPH. You will notice that it is possible to view the other tabs. It is possible to hit unhide, and all the other tabs of PHPP are there. It is recommended not to disturb those tabs, that, you know, to leave those alone, because there's a whole lot of links all set for the easyPH that if you start tinkering with those other tabs, you could actually break a link, or, you know, introduce an error there that could potentially leave your building uncertifiable, which would be, I suppose, a disastrous situation. So I suppose, as a rule, try and just work with the live tabs that are there. If you need your certifier to review something at an individual level, I would generally recommend allow the certifier to do that rather than do that yourself. You know, particularly if you're, you know, a little bit more inexperienced. The more experienced practitioners will understand this pretty well. So I suppose that brings us kind of to the end of our presentation on this today. Barry, if we want to maybe have a Q&A session there for a few minutes, and we can deal with any questions and answers, or anything maybe anyone would like to discuss further.
Indeed, Shane. Yeah. So thank you, first of all, for that presentation.
You're very welcome.
think it concludes the whole series quite well. But I do notice we have 19 here online, so I'm hoping that we have some questions lined up for Shane.
Yeah, fire away, guys. Don't
yeah,
be shy, and we'll do our best.
That's right. So come on in if you have any questions, and we'll try our best to answer them.
Is there anything else, Barry, you'd like me to have a look at, or is there anything you can see from that you might like to explore a little bit further?
From me, Shane, not really. I thought it was quite comprehensive in terms of the way you ran through it. I suppose in the round and the generality of it, you're a practitioner in this space for a long time. MosArt are one of the leading consultants globally on this. Where do you think, or do you think this is really going to drive much more growth in Passive House? Do you think it makes it, really easier now going forward for people to consider certification where maybe before in the past they did not, or they were scared off it? Maybe, I think, again, not answering the question for you, I'm still going to give you the question, but I think for architectural technologists and architects, I think this is a big opportunity for Passive House growth in that instead of having 27, 28 tabs, they're going to only have, 6 or 7, 8, 9, which is much better. So if you want to just answer something around that.
Yeah, absolutely, Barry. I think that's a very important point. Like, I suppose I mean, certainly, I'm sure others have been pushing for it strong, but I know Tomas O'Leary in our office, our managing director, has been pushing for this for a long time to get a single family home approach. And I suppose it's I suppose as certifiers, we certainly have found that single family homes are challenging from both a commercial perspective, but also from a technical perspective. There's a huge amount of data needed for full Passive House certification, and like, you've been through that process, so you know what's required. And look, many projects have the information, but many projects don't, and it can be a real headache for designers to have to go and round up all that stuff. And then I suppose there has to be a review process then by the certifier, and it just takes everybody a hell of a lot of time going the old road. So I suppose this is a little bit like going from a back road onto a motorway. Like, this is very streamlined, it's very quick. You can see there's a hell of a lot less inputs. There's 8 tabs now rather than, as you say, 28 tabs. You're only required to fill out the 8 tabs. The level of evidence required is considerably less than was required in the past, like on stuff like domestic hot water, things like that. There's a lot less stuff to be gathered up. There's just generally less of everything to be gathered up. I suppose that streamlines the process for the designer, particularly those who are working in the single family home field. I think they'll find that the process will be much more streamlined for them, much clearer by just using the easyPH tab. Do your design pH, import your information into your easyPH file, and plug in the numbers essentially. Calculate your TFA, calculate your VN50, plug in your ventilation, plug in your heating, plug in your domestic hot water, and you're kind of done for most projects at that point. Where you've got maybe certain components that need to go in, you can go a little bit deeper, for the more experienced practitioners. Won't be shy about jumping into, heat pump test points and all that kind of stuff. Will come fairly naturally to a lot of people. For those a little bit more wary, can go the simplified approach. So there's lots of options here for both the less experienced and the more experienced practitioner. And I suppose one of the things we're really happy about with this is it's actually going to reduce the cost considerably of certification. Right. And it actually makes it more commercially viable for us as certifiers, which is hard to believe that we could, we can actually reduce our price, but actually make a few quid out of it, rather than the current approach where we're giving quotations for it, but actually struggling to make the pounds and pence add up. So I think for everybody, this is a winner. For certifier and designer, it's cheaper for the client, it's less onerous for the client, it's less onerous for the designer, and it's less onerous for the certifier. I think there's no real losers here. I think that's my appraisal of it.
One other area I'd chuck in on top of that I think it's really going to gain traction with as well. Of course, now I myself am moving away from academia, but if you take the learning space, which MosArt are also in, this will be far easier to penetrate for people, that are just learning it and getting to grips with it. And then also those consultants and practitioners that would do a little bit of rudimentary modeling, but maybe,
I think Barry has frozen on us. Maybe Brian, can you jump in there for a moment?
Yeah, sorry, it looks like we might have lost the connection.
Yeah, I think we lost Barry there for a moment. But yeah, just you're back, Barry. You're back with us.
Yeah.
No worries.
I think you got the gist of it. It was much around just the education space.
Absolutely. I think definitely for the practitioner who's only doing an occasional passive house or whatever, this is definitely it's an easier approach, and for anybody, I suppose, learning the ropes on passive house modeling, if you can master easyPH, then I suppose you're in a good position to go and master the wider PHPP, down the road. So yeah, I think there's a good is a good stepping stone into the wider passive house community. I think it'll open the door to a lot more practitioners to be able to kind of have a little bit more confidence that they can tackle this, and it'll also make it easier for people to learn it offline as well. So yeah, I think there's a lot of positives there. Yeah, fire away.
Which is great, and thank you, Tom Bailey, for coming in with this question. Yep. So Shane, Tom's asking, first of all, he's saying an excellent rounding off the series, which I also agree. So, and a big thank you to yourself. But his question is, can you remind us of the difference in heating demand and heating load between easyPH and standard PHPP using the same project data?
Absolutely, that's actually a very important question, because I suppose PHI have made no bones about this. There is a small penalty, for using easyPH when you're heating demand and your heating load, and that's not by design. It's just, I suppose, to ensure that projects are not been as rigorously reviewed, can still meet the criteria. So typically, I think the PHI estimate it's somewhere in the order of about maybe 0.2 to 0.4 kilowatt hours per meter squared per year, and something in the order of about maybe 0.2 to 0.3 watts per meter squared. Typically that penalty is, so yes, there is a slight penalty there for easyPH, but I think by having that built in, it enables projects to be confident that if they were modeled using the traditional PHPP approach, that they will be able to pass. I'm sure there'll be an oddball case where we'll end up with with a worse result in the real PHPP, or in the standard PHPP, I should say. But I think by and large we're well covered. So yeah, in that sort of order, Tom. I hope that that's helpful.
Thank you, Shane. I think that well answered there, and a good question, as you said yourself.
Very important question. Yeah.
Yeah, we've no other questions, so maybe I'll just round up here with a few words just on behalf of PHAI, I should say. I just think that thanks, Shane. Thanks for MosArt for giving up your time and taking us through that with sort of the lovely blend of nice, candid, relaxed atmosphere, and then also the experience that you have with it all as well. It's been very good. But from PHAI, this is the last in our series, as we said at the start. I suppose just a general call out that with the growth of passive house, both in commercial and also in the domestic space as well, to just keep an eye on the PHAI website. We have some really nice things planned for the autumn and winter coming ahead, and just follow things as they go. We're hoping to have a few announcements soon. And again, just big thanks for everybody that's participated and all the people behind the scenes that have made this happen, in particular Yvonne Coakley and Brian Flax from Core Retrofit here as well, and Caroline.
Barry has gone again there. Okay, we'll give him a moment. Maybe Brian, can he come back?
Yeah, well, just give it a second here, see if he comes back.
Yeah.
I think I'm back again, Shane.
I think you're back. Yeah.
I think it's the electrical storms last night. Maybe
must be.
But from everyone, it's just really to say goodbye, and thank you again.
Thank you very much. Thanks, everyone.